Hey, this is Warren Redlick. Elon Musk just gave a presentation to a group, a scientific group about Starship. His son sat on his lap briefly. That's not what this is about, but gosh, he's cute. Moving on, Elon gave in-depth description of what's going on with Starship and in-depth answers to some really interesting questions. So let's talk about it. Are you ready? Let's go.
That's really the holy grail of rocketry. If you can have a fully and rapidly reusable rocket, orbital rocket, then the cost of transport of a ton to orbit drops by about 2 orders of magnitude, maybe better.
Fundamentally, what Elon and SpaceX are trying to do is they're trying to lower the cost of launching payloads into orbit, improving that cost, lowering the cost by 2 orders of magnitude or better. So a little bit of background here. Before Falcon 9, the cost of launching payloads to orbit was in the ballpark of $10,000 to get a kilogram into low Earth orbit. With Falcon 9, they got the cost down to $2,000 a kilogram. I think internally for SpaceX, their cost of getting a kilogram to orbit is now $1,000 a kilogram with Falcon 9, with all the reusability of the booster. But they aren't able to reuse the second stage. What Elon is saying is, with Starship, with the scale, with the other advantages, and with reusing both the lower stage and the upper stage, they should be able to improve the cost of getting a kilogram to orbit by another 2 orders of magnitude. So if currently it's $1,000 a kilogram to get a payload into orbit, then 1 order of magnitude would be $100 a kilogram. And I think Elon is talking about $20 a kilogram. I don't think they can get to $10 a kilogram, but maybe they can get somewhere between $10 and $20 a kilogram. And he said maybe better, so maybe there's some prospect of doing even better than that. But I believe they are shooting for a ballpark of $20 a kilogram to low Earth orbit. It's hard to give context to that other than to say that it means it's going to be a lot easier to launch large payloads into space to do bigger things in space. And from a human perspective, if you wanted to send a package to London, what would it cost you to send up, let's say, a 1 kilogram or a 2-pound package to London? It would probably cost you like $50. It's going to cost SpaceX less to launch a 1 kilogram package into low Earth orbit than would it cost you or I to send 1 kilogram to London. From a human perspective, it's like, okay, well, it seems like a much bigger deal to get a payload into low Earth orbit than it does to get something to London. That's sort of an underlying goal. That's the underlying strength of Starship, is if you can fully reuse the ship, then you don't destroy the ship on the mission, and you're able to use it again. If you had to crash, if every time you flew, you crashed the plane and had to build a new plane, it would cost a lot to fly. If every time you drove your car, you crashed the car at the end, you had to build a new car, it would be very expensive to drive. So if you can reuse rockets in the same way that we use cars and airplanes, it becomes much, much more cost effective to be able to do the things we want to do in space.
The first orbital flight we're hoping to do in January. So we've completed the first orbital booster and first orbital ship. Will be complete with the launch pad and launch tower later this month, and then we'll do a bunch of tests in December and hopefully launch in January. There's a lot of risk associated with this first launch, so I would not say that it is likely to be successful, but I think we'll make a lot of progress.
Well, hopefully we're going to have the first orbital test launch in January. He kind of flexed on that a little bit, gave it a little bit of room. Later in the conference, he said January or maybe February. If you follow Elon, it's probably March or April. But let's hope for January and see, maybe it happens. Right after that, Elon got into the factory. This is really important. Listen to this.
And then we've also built a factory for making a lot of these vehicles. So this is not a case of just 1 or 2. We're aiming to make a great many. Ultimately, I think in order for life to become multiplanetary, we'll need maybe 1,000 ships or something like that.
I think Elon has mentioned 1,000 ships before, but the general idea is we're going to need a lot of ships because we're transporting a lot of people and a lot of cargo from Earth to Mars. And if you think about, you want to get 1 million people from Earth to Mars, if each ship carries 100 people, then 1,000 ships would take 100,000 people a trip, and you only have a trip every 2 years. And really, the 1,000 starships, not all of them are transporting people. There are tanker ships, there are propellant depots that he's going to talk about later, and there's other starships for other purposes. So if you're going to get 1 million people to Mars over, let's say, a 40-year time span, then you need 500 starships going back and forth on a regular basis, and that it's just going to take a lot of time. And then, the ship goes, it doesn't come back for 2 years. So I almost wonder if 1,000 isn't enough, that it needs more. But this idea that they're not just building a ship, they're building the factory that makes the ships, is really the critical key. That's, it's the machine that builds the machine. It's the same thing with Tesla. It's not just the car, it's the factory that makes the car. This is a critical feature in a lot of ways that Elon thinks about things. Starlink is going to need a machine that builds the Starlink satellites. It needs the machine that builds the Starlink base stations, the station that you have in your home. All of those things, if you can produce it at scale, you can get the cost down, you can deliver a lot more. That's the critical feature. And so Starbase is not just the spot where we're launching to Mars. It's the place where they're learning to manufacture starships in volume. And this was a critical point that he hit. In 1,000 starships, I honestly think 1,000 starships isn't enough for the goal of moving 1 million people to Mars. Unless you're able to cram 300 or 400 people on a journey to Mars, I don't think you're going to get people comfortable with. I could think 100 people could be comfortable on a Starship on a trip to Mars. I think once you go over 100 people on a Mars trip, that's probably going to be tight. So something else is going to have to happen along the way. I'm not sure what. I just want to bounce back to Elon talking about why it's important that we go to Mars and why it's important that we do it fast. So check this out.
I think it's extremely important that we try to become a multi-planet species as quickly as possible. Obviously, along the way, we will learn a great deal about the nature of the universe. And it will be possible to have many more space-based experiments if you have a very large vehicle capable of transporting things to orbit or the moon or anywhere at 100 times less than it currently costs. It offers sort of profound possibilities, and I think there's a fundamental juncture in the history of really any civilization on a single planet, which is, do you get to the second planet or do you not? I propose we do. And I think we should do it as soon as possible. The window of this opportunity is opened now for the first time in the 4.5 billion year history of Earth. It may be open for a long time, or it may be open for a short time. And I think we should be hasty so that just in case it's only open for a short time. Yeah, so like I said, I think this is very important for the long-term preservation of the light of consciousness. And of course, we'll naturally, we'll learn a lot of science and develop a lot of technology along the way.
Elon talked later in the video a little bit more about this idea that there's a short window, that Earth has been around for 4.5 billion years, and it's taken us this long to be potentially ready to become a multi-planet species. And our window might end quickly. We don't know how much time we have before some cataclysmic event happens. At most, we have 500 million years till the sun expands to the point where it boils the Earth's oceans. He'll talk about that later. That idea that we have a limited window of time, and there's a lot of things that could potentially stop humanity from achieving this goal. He talks about some of that later. There's a question and answer that came later where he talked about existential threats to humanity, and that's, I'll bring that up later in the video. There's a nice little bit here where Elon talks about the value of having a larger ship and what scale it gives you, what advantages it gives you.
The vehicle is very big. So one of the things that helps with reusability is scale, because, for example, the electronics that control the brain of the vehicle, if you will, does not actually get any heavier if it is a big vehicle or a small vehicle. So things like avionics and control, inertial measurement, sensors and whatnot become round down to basically almost no percentage of the mass for a big vehicle. Whereas for a small vehicle, obviously, that would be much more of an issue.
That's just one of those nice little engineering tidbits. There's a lot bigger one coming, but it's a nice little engineering tidbit that when you make the vehicle bigger, some of the things that you're doing with the vehicle aren't bigger, so your proportion of mass that's useful goes up because you don't have this extra amount of mass cutting in as much to the share of the ship's mass. Mass is really important. The heavier your ship, the harder it is to accelerate, the harder it is to get to the places you want to go, whether it's getting to orbit, getting to the moon, getting to Mars. All those things are important. So if you can reduce the proportion of the mass that's going to avionics, let's say, or the brains of the ship, that saves you and makes it easier to accomplish other things with the ship. Next here, Elon is going to talk about Raptor and the Raptor engines for Starship. And I think it's really important to look at that in the context of this tweet. He had this tweet talking about 12 million pounds of thrust at liftoff, which is super heavy with the Raptor engine. But coming is Raptor 2, significant improvements, but a complete design overhaul is necessary for the engine that can actually make life multiplanetary. It won't be called Raptor. I'm going to talk about that after, but listen to this clip first about Raptor.
We're using the most advanced engine cycle, which you can extract the most amount of momentum for a given amount of fuel or propellant, which is a full flow gas staged combustion engine. That's the Raptor engine. There are currently 29 of those on the base of the booster. We'll be expanding that to 33. At 33 engines, and with the Raptor 2, we'll be doing about 7,700 metric ton force of thrust on liftoff. So it's about 2.2, 2.3 times the thrust of a Saturn V.
I want to say I thought the panel, you're going to hear a bunch of questions and answers coming up, and I thought they mostly asked good questions. But if you know you're going to have a chance to ask Elon Musk a question, then for God's sake, read his tweets from the week before, because this was a game-changing tweet right here. When he says a complete design overhaul is necessary for the engine that can actually make life multiplanetary, it won't be called Raptor. This was a dynamic opportunity, a spectacular opportunity to say, hey, Elon, you said you need a new engine that's not going to be called Raptor. What did you mean by that? What are your hopes? How do you see that going? That could have been a great question. He might not have answered it, but that would have been a great question to ask him at this opportunity, and nobody asked him that question. Like, well, and I think the critical thing, and he may mention something about this later in the video, is the challenge is to be able to manufacture at scale. I think I mentioned that before. It's about the machine that builds the machine. It's about the machine that builds the machine. It's about manufacturing. It's one thing to make a cool engine, but if it's really hard to manufacture it in high volumes, then you haven't accomplished what you really need to accomplish. You need to find a way to make the engine that will do what you want, lighter weight, more thrust, all that, but you need to make it so that you can make a lot of them, and ideally at a low price. And I think it's probably more about making an engine that's easier to manufacture than it is about improvements to the thrust to weight ratio or whatever you're looking for in the engines. Maybe it's all of that, but it was really striking, and I'm guessing in the next 2 or 3 months we're going to get an answer to this question. It would have been nice to have the answer right now, because I'm a nerd and I want to know, wait a minute, what are you doing with it? And I'm sure everyday astronaut is like flipping over, like trying to figure out, wait, what is he doing here? So hopefully somewhere down the road we'll get an answer to this question. The last thing I'm going to mention from the main part of Elon's talk is when he talked about launching a space telescope. He has mentioned this before, but this is something that Starship will enable that previous rockets couldn't do because of the scale of the rocket, the 9-meter diameter, because of the thrust that it has. This is going to make possible things that weren't possible before. This is an example.
We have an interesting project that we're working with Seoul Motor at Berkeley on, which is to have a really big telescope. This is taking a ground-based lens that was intended for a ground-based telescope and creating a space-based telescope with it. So that could be, I think, pretty interesting, and we'd love to do other things as well.
As you know, the satellite constellations from Starlink and other sources are already having a huge impact on astronomical observations, and this is really going to significantly limit the science potential of the next generation of observatories if we don't have a course shift. So what role do you expect SpaceX to play in working with astronomers and regulatory agencies to mitigate this?
SpaceX already works with regulatory agencies and with the astronomers. Generally, what we see is the telescope that is perhaps most sensitive to this is Vera Rubin. And we work directly with the Vera Rubin team to make sure that their observations will not be affected by Starlink satellites. My understanding is at this point they are comfortable that it will not be an interference for Vera Rubin. There's a slight risk of capacitive coupling between some of the sensors there, but which can create ambiguity. But we're confident that we can work around that.
So there's 2 reasons that was a really annoying question. One, he just told you that SpaceX is going to launch this telescope, a space-based telescope using a ground lens, a lens intended for the ground. They're launching something that's going to help astronomy massively. And you totally ignored that he just said that. Were you listening when he talked about that earlier? Did you listen to what he said before? Second, he's been asked about Starlink interference with astronomy multiple times. He's answered this question multiple times. He did give the best answer yet to the question, but he's basically said, look, we're working on this. We're working with astronomers. This time he laid it out like he obviously knew more about this problem than she does. And he's saying, I don't really know that much about it compared to my team. This is the astronomy location. This is the telescope that has the most issues. We're working with them. They're satisfied. Like, why did you ask this question? Did you see that he's answered this question multiple times before? Did you talk to anybody in the astronomy community to find out whether this matters? Or did you just read some news article where somebody said there's a problem with Starlink? It looks to me more like she only looked at some media stories about this instead of actually talking to people who do astronomy. She didn't have a comeback. She didn't have a, well, wait a minute, I talked to these people about this. It came off as an uninformed question. It was just really annoying. As somebody who loves listening to Elon, I get really frustrated when he gets asked questions he's already answered before. I did appreciate this nugget that he gave us. Didn't come from her. This nugget he gave us about this different observatory, I thought that was really helpful from Elon, but it was just the worst question. The rest of the questions are better. That was the worst question he got. It's also not really relevant to Starship. He gave a talk about Starship, and you asked him about Starlink. The talk was about Starship. Why are you asking about something different than what the talk was about? He just told you they're doing a space-based observatory. Why didn't you ask him, how cool is that going to be? What can we do with that? There was so much better you could have asked, and instead you went for the criticism instead of the exploration and find out something more interesting. Very frustrating, but I promise you the remaining questions are better. Okay, this next bit I think may have actually been a part of the talk, but I have it marked in my notes as a question. I'm not sure whether I got it right or wrong. But this is Elon talking about using Starship to get people and materials to the moon to create a moon base. It's pretty quick. I just think this is a good bit.
It has the ability, because of the mass transport capabilities of transporting enough mass and people to the moon to actually have a permanently occupied, I think, base on the moon. Much as we have like a permanently occupied base at Antarctica, we could have a sort of a moon research station, which I think would be amazing.
Moon base sounds cool. And there's another question that talked about research on both Mars and the moon. Elon talked quite a bit about that. This is a little bit longer. I'm kind of taking shorter questions and answers and then going to longer ones. So my favorite one is at the end, talking about stainless steel for Starship. But let's go into this one about how Starship will help benefit science.
You could share a little bit more when you think about the aspects of scientific discovery that will accompany becoming a multi-planet species. What are the kinds of things that you're thinking about in terms of what we would discover along the way?
Being able to really, have heavy-duty science research on the moon and on Mars, where you could really just go anywhere you want, drill core samples anywhere you want, I think we'd learn a tremendous amount as compared to having to send fairly small vehicles with limited scientific instrumentation, which is what we currently do for Mars and the moon. Just having people there who can dynamically decide what they're going to do and really being able to analyze the whole history of the planet, I think would learn a tremendous amount. And that would obviously extend over time through at least the greater solar system.
So that was the meat of his answer to the question, that we'll be able to do a lot more science on the moon and on Mars, and maybe we get to Europa, maybe we get to Ceres, and we're able to do on the planet or on the asteroid or on the moon science with humans there to make decisions in real time, as opposed to having small probes doing things. We'll have large amounts of payload to be able to do much more substantial research and learn a lot more about the planets, the moons, and the solar system itself. Then Elon went into some more philosophical realm and a little bit joking.
I mean, I studied physics because I was just trying to find out what's the universe all about? How does it work? Where did it come from? Why are we here? I actually kind of got sort of depressed at one point because I was like, man, this doesn't seem to be any meaning to life. It just seems to be like, and then I made the mistake of like reading the German philosophers as a teenager. That made it was quite depressing. But then I read Douglas Adams' Hitchhiker's Guide to the Galaxy, which is really a book in philosophy disguised as humor. And he makes a point that the question is harder than the answer. And really, basically, the answer is the universe. We kind of need to figure out like what questions to ask about the answer to that is the universe. And that's the question is the hard part. And then the answer is easier by comparison. So I'm like, I don't know, like why are we here? How do we get here? Is this real? Is this is this simulation or something? At least if we go to these other planets, we'll make the simulators work harder and have to buy more computers to run the simulation or something.
Then Elon got into a little bit more back into the meat of the question, exploring the solar system, potentially going beyond. And that'll come up again in a later question.
If we are able to at least be a multi-planet species within the our solar system, then hopefully we can develop the technology to send probes to other star systems, and eventually maybe send people. Although that's tough, but we can certainly send robot probes to all the nearby star systems. Yeah, try to figure out what's the meaning of life and what's going on, and are there any aliens out there? Where are the aliens? They're so soft.
Yeah.
One of the things I think is really special about Elon is his ability to, on the one hand, talk about a very serious subject, and then in the middle of talking about that serious subject, go into the simulation or where are the aliens and laugh while having a serious conversation. I just think that's one of the beautiful things about Elon. Next, we're going to dive into a question about when will Starship be ready for customers to use it to launch payloads into orbit?
When do you think you will be able to start selling Starship launches at prices significantly less expensive than Falcon 9, say 5 to 10 times less?
Actually, I think it's not that far away. I think probably 2 years from now. Our rate of progress on Starship is very rapid. We're actually getting ready to do our first global orbital launch attempt within the next few months. We're expecting our license approval from the FAA around the end of this year. And then so that probably means a launch attempt in January or perhaps February. We're actually building the factory to make lots of Starships and make lots of engines in parallel. So there will be many vehicles. The engine build rate is currently the biggest constraint on how many vehicles we can make, because there are currently 29 engines on the booster, and there will be 33 even at a higher thrust level. That means so 33 engines per booster, and these are big engines. These are the Raptor 2 is a roughly 240-ton thrust engine. So we're talking like 500 or 600,000 pound thrust engines. In fact, I'd say that building the production system for Starship is much harder than the design of the Starship. But we have that in progress, and we intend to do hopefully a dozen launches next year, maybe more. And if we're successful with it being fully reusable, it means that we build up the fleet, just as we are with the Falcon 9 and the Falcon 9 booster, which is reused. We lose the upper stage every time, but we almost always recover the booster. So basically, we intend to complete like the test flight program next year, which means that it's probably ready for valuable payloads that are not kind of in the test, not for testing basically, but actual real payloads in 2023.
Well, that one was like drinking from a fire hose. There was a lot of information there. Number one, we expect the first orbital test launch to happen in maybe January or February. There's this bit about the Raptors producing Raptors at scale is a huge challenge. Elon specifically said we need a design overhaul to make the engine that can make life multiplanetary. It won't be called Raptor. And now he's talking about the challenge of manufacturing Raptor at scale in this conversation. I think he talked about that once before, maybe on Twitter, that this is like the current hurdle they've got to overcome is, can we make enough Raptors? And maybe that's leading towards why we need this new engine. Elon's expecting about 12 test flights in 2022. One of the other things he mentioned today was that it's unlikely for early ships to splash down intact. This was in response to a tweet showing Starship being recovered. He said getting to orbit at all on first try would be a major win, and long-term the ship would land on tower arms like the booster. As I understand it, the plan is for the orbital launch is that the rocket will come back and try to land vertically in the ocean off Hawaii. Elon is saying it's unlikely it will splash down intact. It's probably going to burn up on reentry. That it would be amazing. It would be good if it just gets up into orbit and is able to come back down. But whether they're able to achieve actually doing a wet water landing where it propulsively lands in the water. He doesn't think that's likely at all. Not just for this first test orbital launch, but even for subsequent orbital launches. I think they're still having problems getting the heat shield tiles to stay on properly. And so that's probably what's going to blow up the ship on its way in. But we'll see. So Elon, in response to the question, expects that commercial payloads will probably start flying in 2023. It was a little unclear there. He said that they'll be doing test payloads in the 2022 launch sequence, the 12 test launches. I wonder if some of the test launches are going to be Starlink satellites, because a primary mission of Starship will probably be to launch Starlink satellites. There was an animation done of Starship launching Starlink satellites. It would greatly lower the cost of getting the Starlink satellite network into orbit. So that seems like that might be one of the payloads in 2022. I thought it might happen sooner, but it almost sounds like they're going to push the Starlink payloads out until 2023 as well. My gut is they're going to do a Starlink launch sometime in 2022. Once they get orbit down, even if they don't have reuse down, once they get into orbit successfully, then they might as well launch Starlinks while they're up there and then see if they can bring it back down and land it. Another key detail there is just Elon saying they're making rapid progress on Starship. He talked about that with Tim Dodd, Everyday Astronaut, that they need to innovate with extreme urgency. And I think at times he said they're not moving fast enough, they're not making progress fast enough. It's a very positive sign for Elon to say we are making rapid progress, because he's normally kind of down on the progress and we need to go faster. So something good is happening that he feels like they're making rapid progress with Starship.
What type of international collaboration do you see to get this done? And, what are the possibilities of actually pulling that off?
Well, we're not assuming any international collaboration. We're building this thing right now. We're really building it from internal funds. NASA is providing some support. They intend to use Starship for transporting astronauts to the surface of the moon. But this has really been an internally funded effort, probably at least 90% internally funded thus far. And we expect to reach orbit, probably, I don't know if we'll get there on the first attempt, but I'm confident we'll get there next year, and we intend to have a high flight rate next year. It's difficult for us to actually have international involvement because of ITAR. So I'm not sure. I don't really see anyone outside the US who is building some part of what we need.
I just thought this was funny because the way he asked the question, I'm not sure if he meant international cooperation to go to Mars, but international cooperation to build Starship. Elon just poo-pooed that. We're building it. We don't need international. We're building it ourselves. NASA's helping a little bit where we're building it ourselves. And there's not really anyone internationally doing anything that would be helpful. So it was kind of a pretty strong statement of we know what we're doing fine. We don't need any help. Very impressive. And of course, technically from US legal rules, trade rules and technology rules, they wouldn't be able to collaborate internationally on rockets because rockets could effectively be used as missiles, as weapons of war, as, like international ballistic missiles, that type of thing. So the federal government doesn't want SpaceX sharing that technology with other countries. There's a lot of questions about Mars. Next up is a question that I feel is kind of a dumb question about planetary protection. People ask this question, but it's pretty obvious, and Elon pretty much knocks this out of the park. Have a listen.
Our committee is concerned with preserving the validity of future astrobiological experiments on Mars and other places in the solar system.
Yep.
Searches for life, extinct or extant. And I wonder if you can comment on SpaceX's planetary protection plans for Mars.
Well, first of all, it's not like we'll be launching to Mars really soon. Mars is a ways off, but there is fundamentally a choice to be made, which is, are we going to try to be a multi-planet species, which would mean like at least in one spot on Mars that there is human biology, like that we're pretty hard to avoid no biology if you send humans there. We're biological creatures. But I don't think this is going to invalidate research on the rest of the planet. Mars is a big planet, and so and there've been rocks that have been knocked off of Earth and landed on Mars and that kind of thing. But yeah, I think you wouldn't want to sort of spread biological debris all over Mars, but I think we will have to put at least somewhere if there are people going there, at least in one spot. and then just make sure we try to contain that and not have it sort of spread around. And I guess it's same for the moon and other places.
This just seemed like a no-brainer. Obviously, if we're going to land humans on Mars, then we're going to have biological contamination on Mars. It's unavoidable. And I love at the very end, Elon extended that it was not just about Mars, but it's about the moon and other places that humans might visit. That it's important to minimize biological contamination to the extent that we want to do scientific research to see whether there was life on this rock before humans landed there. Because if humans land there and bring biological material with us, we can contaminate the sample and make it hard to tell whether what life may have been found on that rock was there before humans got there or is the result of human presence. And, you know, when we got there, maybe we spread this life and we thought it was actually there before and it really wasn't. And how do you tell the difference? It's an interesting question, but really, if the goal is to make life multiplanetary, that's a little more important than this particular tiny scientific issue that's not trivial, but making life multiplanetary is just a more important goal.
You have to preserve cryogenic propellant for 6 to 8 months to actually be able to land on Mars. I wonder what your plan is for that.
The landing propellant for Mars would be in separate header tanks. So these would be spherical header tanks. For Mars, there would probably be, they might be contained inside the main tanks, or they would be up in the cargo section, but well insulated. You would obviously have to have extremely well insulated header tanks for landing that are not the main tanks.
Interesting technical challenge. You've got this cryogenic propellant. You've got to keep it cold and you've got to keep it in the tank for 6 to 8 months is the way he put it. I think it's about 6 months. Maybe it's 6 to 8 months depending on how you're doing it. And so Elon said we'll have to have special header tanks that are separate from the main tanks or maybe contained in the main tanks that are really, really well insulated. And that enables them to keep the propellant ready to go for when they get to Mars. I've actually wondered about this challenge myself. I think another question is, if you're going to take off from Mars again and come back, are you going to, because there's some versions of this story where you bring the fuel with you to Mars and now you got to keep it for 18 months. So again, you're going to have well-insulated tanks and you're probably going to have to use some electricity generated by solar to keep them cold. I guess. I don't fully understand the mechanics of it, but that's just that's a little bit of a nerd tidbit. I hope you liked it. Speaking of nerdy stuff, and speaking of propellant, this is one of my favorite moments in the talk was when Elon was asked about orbital refueling. Elon brought up the concept of a propellant depot, a Starship specifically designed to hold fuel in orbit. Listen to this.
I realize, or I believe, that your architecture for Starship to go beyond low Earth orbit to go to the moon has, cryofluid transfers and things like that, and long-term cryofluids, cryofluid storage, low boil off.
Oh, yeah, not easy problems.
No, and so not easy problems. So the question I have for you is what are your plans to mature that technology, but before you have to rely on it to go to the moon, like in a year or two?
One of the ways to address it by launching one vehicle that is very well insulated, but does not return to Earth, effectively a propellant depot. So if you take a Starship, and you take the heat shielding off and replace that with thermal insulation, like a multi-layer insulation that's just very, very good at keeping things cold. Then you could have one ship up there that it effectively just turns into a propellant depot, and then you send tankers up there to dock and transfer propellant, and so it should be able to be there for a while. And then whatever ship you want to go to the moon, you go up and dock with the depot, transfer propellant, and off you go. So that's a rough plan. We're pretty good at docking at this point. We've docked with the space station couple dozen times. And the space station is a very difficult thing to dock with because we don't control both sides of it. That is very challenging docking, whereas docking with our own vehicle is comparatively easier.
But both of these technologies have really only been demonstrated on very, very small scales. So your scale is a lot larger, and I think poses other problems. So good luck in solving those.
Yeah, no, I don't think we'll just sort of it's not exactly a walk in the park. So I think this is hard, but it is necessary, and it's the only way, at least with that I'm familiar with current physics, to actually make things work. Aerial refueling is used quite a lot with aircraft. And so this is, taking that concept and just doing it in orbit. We know that success is one of the possible outcomes. We're not breaking any physics. Physics is the law and everything else is a recommendation.
If you follow my channel long enough, you know I made a t-shirt with Starship, different versions of Starships, because Elon had talked about stretching the tanks and different configurations of Starships. I made a t-shirt with a bunch of different possible Starships that might exist. I didn't think of a propellant depot Starship. T-shirts, by the way, are at elonbits.com, the Tesla and Air shirt, the Starship shirt, all kinds of t-shirts, and the stainless steel water bottle, all there on elonbits.com. But, do I have to make a new shirt with the propellant depot Starship? I'm not sure. And the key there is the ability to reconfigure Starship. If we launch it and we don't put heat shield tiles on it, we plan on it not coming back to Earth, that saves mass. I suspect you wouldn't have to have the fins because it's not going to come back. So you're not going to need the fins to steer it when it enters. You can save a lot of mass if you know you're not going to be bringing it back in to land. And you can use that mass to allow you to have better insulation and to hold more fuel. So I think that's the idea. Hopefully we'll see more about that. Maybe 2023 is my guess. Well, guess what? We've got more about Mars. Are you ready?
What are your kind of plans for humans to Mars in terms of timescales and are you going to send folks there for kind of a shorter stay, or you think a longer stay and bring them back, at least initially?
I'm not sure. I think so. The first thing we'd want to do is confirm that we can land the ship safely on Mars, and so that might be we'd want to probably land 2 or 3, I think, before sending people, and just confirm that we can land safely. And actually on those missions we could obviously put a lot of scientific instrumentation. I would recommend putting the lower cost scientific mission stuff on the first mission. But we'll certainly have propulsive landing very reliable on Earth, as we've been able to achieve with the Falcon 9 booster. And we'll do the same with Starship.
So there's a lot more to this answer, but I want to just break in here and just point out that Elon says that the plan will be to do 2 or 3 missions to Mars, uncrewed missions, with some sort of scientific instruments on them, but the low-cost ones in case the missions fail, with the idea being that we do 2 or 3 test landings on Mars and make sure we've got that down before we try to land humans on Mars, because we want to make sure we can land safely on Mars with uncrewed ships before we try to land on Mars with crewed ships, because we don't want to lose people. And we don't want to use the most expensive scientific equipment when we're landing on Mars with the first missions, because we don't want to lose the most expensive equipment when we do those landings. And he talked about that as if SpaceX is just going to do that themselves without bringing NASA into it. And now he's going to talk about NASA's role. And he's going to kind of go off on a tangent about existential threats to Earth and dangers to continents, and kind of interesting little bit here, but didn't really address that question. He just kind of went off on a tangent about the importance of becoming a multi-planet species, really.
I'm not sure quite what would happen. I mean, we might be working with NASA, or maybe NASA and other countries to send people to Mars. But I view this very much as, what set of actions can we take that maximize the probability that the future is good for civilization? What are sort of like civilizational risks that we can potentially mitigate? I just think being a multi-planet species is a tremendous risk mitigation for human civilization. As we know, eventually Earth will become, if you wait long enough, Earth will become uninhabitable. In the long run, we're obviously all dead. The technology that we develop in traveling from Earth to Mars, I think will be just a very powerful forcing function for the improvement of space transport. Like the initial boats that crossed the Atlantic and crossed the Pacific back in the sailing days were really terrible. They would often just plain sink. Once there was a reason to do large amounts of ocean trade, the sailing ships, the wooden sailing ships, got dramatically better. But you kind of have to have that forcing function. That's what I think will happen, and we'll get much better at space transport. And I think this will also be very important if there's like a potential Earth collision event from some comet or something like that. The asteroids we can predict fairly well, obviously, but there's this massive cloud of comets out there that we don't know the situation, and they come in pretty fast. So there's always some risk of a comet like taking out a continent. There's this place like they talk a lot about extinction events where almost all life was destroyed on Earth, but they don't talk that much about the ones where, well, it was just a continent. There's plenty of sort of continent level extinction events that have occurred in the fossil record, and they're like really so common as to really not really generate much attention. But if we've got large rockets that could potentially do something about that, then that could be, that could at one day save billions of people. But we've got to have big rockets and much more advanced space technology in order to protect against a comet coming in from far away.
I was struck by how he ended that answer in the context of what happened recently with Bernie Sanders ranting about billionaires shouldn't be deciding our fate in space. Elon Musk is talking about really important issues that need to be addressed. Bernie Sanders has no clue about this stuff. Joe Biden has no clue about this stuff. The Republicans have no clue about this stuff. Elon has a much better vision for how to keep our planet safe than any of these yahoos in Congress or the White House for the last 20, 50 years. I don't care how long. For me, this was a really striking contrast. Like, do any of you think that Bernie Sanders would be better placed to decide on planetary defense than Elon Musk? Do any of you think that Joe Biden or Donald Trump or Mitch McConnell, that any of these yahoos in Washington have any clue what's going on here? I would give Jeff Bezos a shot at this over any of them too, even though Bezos isn't that popular in SpaceX fan community right now. Very clear that Elon gets it. I'm pretty sure that Jeff Bezos gets it, and very clear that nobody in Washington has any idea what Elon's talking about here. And it's really important stuff. We're talking about, something that could wipe out a continent, and there's one person here who cares about it. Anyone in Congress care? I haven't gotten a hint of anybody in Congress who cares about this stuff. So there's 3 more bits left. Since we just talked about existential threats, we're going to cover the one more question about existential threats. Then we're going to talk about radiation affecting astronauts on their way to the moon or Mars. And then we're going to talk about stainless steel on Starship, the nerdgasm I had over the engineering decisions that went into going from carbon fiber to stainless steel. So first, let's talk a little bit more about existential threats. This is a long one.
What do you see as the biggest threats? And in particular, we have a wide range of expertise here. We've been talking about some of the problems that we think are the most important that are unresolved yet. I just wonder what you felt were the most important issues for us as a human race.
In general, I've thought about this quite a lot. Which is not to say that I've thought about it correctly, but I've thought about it a lot. One of the bigger risks on Earth would be, that we need to transition to sustainable energy. Even if one discounts the CO2 capacity of the oceans and atmosphere, eventually we will run out of hydrocarbons to burn. And so we need something that's long-term sustainable. I kind of split my time between Tesla and SpaceX. And so Tesla's trying to accelerate the advent of sustainable energy. And that's, to mitigate the risk on Earth. And then SpaceX is intended to mitigate like longer-term risks that could potentially extinguish consciousness as we know it. I mean, we got the sort of delicate candle of consciousness sort of flickering in the darkness here. I don't know if you guys have seen any evidence of aliens, but I sure haven't. I get asked that a lot. I often think the Fermi paradox is just an incredibly interesting question. There's either a lot of aliens or none, and equally, those answers are equally terrifying. But with respect to nearer-term risks on Earth, obviously sustainable energy and potential nonlinearities in the CO2 ppm in the atmosphere are a concern. If we start doing things like melting the Siberian tundra and that kind of thing. I'm probably less alarmist than most on climate change. I'd put myself in the moderate category on climate change. I just think it's the amount of inertia associated with the hydrocarbon economy is so gigantic that it will require a long time to make that transition. And so it's probably better to start it sooner rather than later. And that's why I describe fundamental good of Tesla as the degree to which it accelerates the advent of sustainable energy. It will happen, I think, anyway, but faster is better. Then as for risks on Earth, I mean, there's always good old nuclear Armageddon, that's still one of the things. That's not out of the question. There's still a lot of nuclear missiles pointed at us in the US and many parts of the world. I don't know what quite that risky is, but it's not zero. I think there's maybe some counterintuitive risks or that people don't put that much attention on. If you look at the birth rate trends, the birth rate trends are very negative. And in many countries are seeing population decline with no end in sight. So very low birth rate, I think, is actually quite a significant risk, but an underappreciated one. And for population prediction, I would recommend taking things like the number of babies born last year and just multiplying that by the probable lifespan. And if you do that, I think you'll see numbers that are very, very bad for future population. And with an inverted demographic pyramid. So you've got a lot more older people and then fewer middle-aged people, and then eventually just very few youngsters. And this will necessarily lead to resources being applied to taking care of the elderly instead of advancing science or advancing civilization. I'm quite worried about that one because I see no reversal of the trend. That would, civilization will die with a bang or a whimper. That would be dying with a whimper.
I just wanted to point out again here how you see Elon Musk is talking in depth about important issues that threaten humanity itself. And can any of us picture Joe Biden, Bernie Sanders, Donald Trump, Mitch McConnell, pick your Republican, pick your Democrat? Are there any of them that any of us can see as really thinking about this at the level of depth and talking about this at the level of depth that Elon is talking about it here? The existential threat of low birth rates is something that you very rarely hear people talk about. And Elon is putting it like, this is dying with a whimper, but this is apocalyptic. If people don't have kids, then the population dies out. And that can prevent the light of consciousness from spreading throughout the galaxy or surviving at all. If the population halves and then halves again and halves again at a certain point, and if the resources are devoted to taking care of seniors instead of advancing science and advancing technology, which you can clearly see that is the way Congress thinks. We got to take care of Social Security and Medicare are like things you can't touch, but you can cut science easily, right? Because seniors vote. So there's the way the political system works pushes this agenda, and we really, truthfully, need people to have more children, and we're not getting there. And then we're focusing our resources on taking care of the elderly instead of taking care of the future. This is pretty striking. And I see this in depth in the way I look at politics. And I'm really glad we have Elon around, but we're going to need more of us to do more in this direction. I don't know if we're going to get out of this hole. This is a pretty big hole we could be stuck in. This might be the one that does in humanity. Forgetting about nuclear war or the sun expanding, it could just be we die with a whimper.
Then there's obviously, of course, a pandemic that's like COVID, but which has a much higher mortality, sort of a long, high contagion, highly contagious, long incubation period, high mortality type of pandemic. That's clearly a risk. AI is, I think, maybe more of a risk than people realize. Ironically, the smart people tend to think AI is less of a risk because they think that they're so smart, but actually we're just humans and we're quite dumb. It's amazing we got this far, frankly. If you see the advancement of AI, it's clear that AI will exceed human intelligence in every way if these trends continue. And the list of things that the human mind can do better than AI is less and less every year. Hopefully that AI is coupled to human will, but it might not be. The long-term goal of Neuralink is to achieve sort of better symbiosis with AI and with the kind of human mind. In the short term, Neuralink, I think, will help solve a lot of brain injuries and diseases and spinal injuries and that kind of thing. But long term, because one of the things that I'm getting quite esoteric here, but we're already a cyborg, really, in the sense that our phones and computers are an extension of ourselves, and you could say we arguably have the primitive kind of limbic system, the cortex, the higher thinking. And then we've got a tertiary layer, which is silicon in the form of our computers and phones and everything. we have already somewhat merged with computers. But the issue we have is the communication rate. The bandwidth with the computers is low, especially output. If our output is 2 thumbs, that's, we're talking maybe 10 bits per second or something like that. No, or maybe 100 best case. It's a very slow output. And as the intelligence of the computer grows, if that communication link remains very tiny, I think we will necessarily decouple from computers just because our rate of communication is very slow. And so if we can solve the I/O bandwidth question and by, increase it by 1,000 or more, maybe 1,000,000, then you could have human machine symbiosis that is much better. I mean, that's at least one approach. I mean, religious extremism, if that becomes, if that grows over time, religious extremism is certainly a threat to advancement of science. So depending on how far that goes, that could be an issue.
I will only add, I think that this is a fundamental question because, as you said, the Fermi paradox, should either be a tremendous number of alien civilizations, or there is some gate that so many civilizations have failed to get past. And the question is, are we going to fail to get past that gate as well?
The great filters. So I think at least one of the great filters is, does a civilization become multiplanetary or not?
Yes.
If a civilization does not become multiplanetary, then eventually the sun's going to expand and boil the ocean, and that's game over. So, and actually, if you think about it from a percentage standpoint, if Earth's been around 4.5 billion years, and it took us 4.5 billion years to get this far, well, it may be as soon as another 500 million years, and the sun might have expanded enough by that time to boil the oceans potentially. It's not 500 million years; it's not much beyond that. Which is basically means that if it took 10% longer for civilization to evolve, it would never have evolved.
Okay, moving on to the Rocket Evolution t-shirt. Next up, we're going to talk about radiation affecting astronauts, what SpaceX might be able to do to protect them, both in flight, on the moon, and on Mars.
What are you doing for radiation protection for the crews? And if you have you explored the need for forecasts of the space weather conditions or the space weather environment?
There's always some risk going into deep space. We definitely wouldn't want to be traveling when there's like intense solar storms or anything like that. Before going to the moon, like obviously, the United States has done that before, and it would be great to go back and great to have a permanent base where if the costs are good enough, where we could have like a significant science contingent actually on the base, permanently occupied. It would be epic. But once you're on the moon, of course, you're protected by the moon below you, and then you can put a lot of lunar regolith on top of whatever the research station roof would be. Once you're there, easy to protect. On the way, we'll have to check the weather report. And for Mars, it's going to be trickier. Obviously, we don't have all the answers here, and there may be some clever ways to reduce radiation effects, but I don't think they're insurmountable.
Radiation is a concern for astronauts, and they have to take certain measures. So the trip to the moon is fairly short, and as long as you have a good sense that there won't be solar storm activity, I'm not sure how they know that, then you'll be able to get to the moon. And once you're on the moon, like Elon said, once you're on Mars, the moon itself protects you because the sun is on the other side of the moon most of the time. And then you build a structure and you put regolith, which is basically Martian dirt or Martian material that you take from the ground on Mars, and you put that on top of whatever your structure is. And just a foot of it or some, I forget exactly how much you need, a little bit of that is going to protect you from radiation from above. And you're basically covered most of the time. And every once in a while you go out, ideally you go out when you don't have the sun shining on you on the moon because there's no atmosphere to protect you. The trip to Mars is much longer, so it's more challenging to protect the astronauts. And Elon didn't really have an answer to that question. I know people have been working on this question for a long time. I think the theory is that you carry a lot of water with you on the trip, and you design the ship so that you have water around a certain area. And when there is a solar storm, the astronauts go in the area that's surrounded by water, and the water protects you from the radiation. That's a theory. And then once you get to Mars, the same story is on the moon. The planet protects you most of the time from the radiation, and you use Martian regolith. Elon has answered that before. you build your structure on the moon and you put stuff on top of it from the Martian surface, and that will protect you from radiation as well, and you don't need that much of it. I personally think there's a chance SpaceX will use boring company machines to bore tunnels on Mars, but Elon has definitely not talked about that as an idea. So whether they'll do that or not, who knows? Next up, a question about the outer planets.
SpaceX is giving the Europa Clipper a lift at Jupiter. I wondered if you have comments on other missions that you would like to enhance by providing big lifts.
Sure. Actually, we're really excited and honored to be flying the Clipper mission. There could be some incredibly exciting things to discover, hopefully are, under Europa. Seems like probably the best place for some strange life. So hopefully we find some really cool things. So yeah, I can't wait to launch the Clipper. That'll be on a Falcon Heavy currently. With the Starship, we could, like the great thing about Starship is it really should enable us to send very big things and also to send them fast and like need much less in the way of sort of planetary gravity assists and that kind of thing. Especially if we could build a propellant generation on the moon, then we could really send something with very high delta V. If we have a base on Mars with high delta V, now you can basically planet hop from Mars to maybe Ceres, to maybe one of the moons of Jupiter, and ultimately all the way to the outer solar system. Basically, any place we can put the gas station, that gives us another whole leap forward. Ultimately, Starship is designed to be a generalized transport mechanism for the greater solar system. And so it's really whatever you can imagine being, if you could get, a 100-ton object to the surface of Europa, there's a lot more you can do than with a smaller object. Yeah, I think it's very exciting. Obviously, we still have a lot to prove, but architecturally, it is capable of transporting kind of almost any arbitrary mass to any solid surface in the solar system.
I love this concept of planet hopping or maybe rock hopping. You get to the moon, if you can make propellant on the moon, then it's easier to travel from the moon to other places because the moon has such a small gravity well. The gravity is 10% of Earth's gravity, so Starship on its own can take off with no need for a booster and go delta V. You need to go fast to get further out in the solar system. It's about speed. Also to go further in to some extent, you need delta V. You need to change velocity to get to where you want to go. You get to Mars. Mars has about a third of Earth's gravity, a little more than that, but still a small gravity well. Starship on its own without need for a booster can get out and do significant delta V and get further out to the asteroid Ceres or Ceres. And then from there, maybe out to the moons of Jupiter. A lot of potential. And then once you can establish a base and produce propellant somewhere in the solar system, that enables greater hops to go further out in the solar system, to explore more and more and more. Really, really good stuff. Nice to hear Elon talking about that. I don't think Elon is particularly focused on those missions. He's focused on creating the ship. That was kind of his big point. Creating a ship that can take large payloads and with high acceleration, with high delta V, can accomplish whatever missions you want better than ships that can't do that. So it's really enabling whatever it is that people decide to do with this technology. And then, as he talked about before, once you make some progress in planetary transport, that's a spur to further development of new technologies to make it happen even better. Okay, and last but not least, this was my favorite part of the talk. There was a question about why SpaceX chose stainless steel over carbon fiber or other alternatives like aluminum-lithium. And Elon gave a really, really in-depth explanation. This is absolutely brilliant. I saved the best for last. It is long and it's worth it if you're into the geekiness. Are you ready for this? Let's go again.
I believe you chose stainless steel for the vehicle. I could be wrong, but what were the technical and engineering reasons for that? And don't stint on the details.
Because to a lot of people, intuitively, they would think of steel as being heavy. And rockets need to be light. So, well, that seems a pretty odd choice, picking a heavy sounding thing for rockets, especially orbital rockets that need to be very light. The nature of Earth's gravity being quite strong and a dense atmosphere means that you really have to have an incredibly good propellant mass percentage, and you have to have very efficient engines to get anything to orbit at all. We started off with an advanced composite. So intuitively, if you ask people understand materials, they will say, we want to make something incredibly light. They'll say, probably you want to use state-of-the-art carbon fiber composite. That's usually what they'll say. And that's what we started out with, which was really a very advanced carbon fiber. Actually, it was only made in very small quantities. It cost $130 per kilogram, so it was very expensive material. And there are some challenges if you want to make the primary structure out of carbon fiber, which is that you've got to contain cryogenic fluid, and you need gas in sort of what's called ullage gas, pressurization gas, to pressurize the propellants in the main tanks and feed the engine turbopumps with a given inlet pressure. So if you have a carbon fiber tank, because it tends to be porous and also potentially flammable when subject to warm gaseous pure oxygen, because our vehicle is autogenously pressurized. So the oxygen tank is pressurized with gaseous oxygen, and the fuel tank is pressurized with gaseous methane. The resin and the carbon in the carbon fiber is potentially flammable with hot, pure oxygen gas. So you'd have to have some kind of liner. So when you look at the full mass and complexity of a carbon fiber system, you start having things that reduce the mass efficiency of carbon fiber, such as having an inert liner and being worried about gas permeating through the carbon fiber and that kind of thing. So, but it still would be it's still an okay choice. However, we were having a lot of trouble making progress with carbon fiber because this is a 9-meter diameter rocket. And so you're wrapping carbon fiber with typically, in this case, 60 to 120 plies, depending upon where you are in the tank. And you have to get all of those wrappings accurate and not leave bubbles or separator sheets or all the things that typically happen, or you've got to scrap the whole thing. And then you've got to get good mass properties, put it in an autoclave and put it under a lot of pressure. And then you need a gigantic autoclave because it's a 9-meter diameter with a 70-meter long boost stage. So this is autoclave from hell. And we just weren't making rapid progress with this material. So then the next thing, the other two materials worth considering are high strength form of aluminum, or potentially steel. So for Falcon 9, we use aluminum-lithium, which is the highest strength to weight aluminum alloy that you could use. Very difficult to weld, but that's what we use for the primary structure of Falcon 9. But the problem is it's very difficult to weld. You need to do friction stir welding, and also the material cost is quite high. That's sort of material cost, arguably on the sort of $40 a kilogram level.
I just want to interrupt really quick to say that was a pretty good rundown on the problems with carbon fiber and aluminum lithium. That carbon fiber, and there's going to be more as he talks about steel next, but carbon fiber, very expensive, difficulty innovating. It was hard to make progress with it. Aluminum lithium, expensive, hard to weld. And then the weight advantages aren't necessarily what you think they are, because if you use carbon fiber, you have to do these other things that make the carbon fiber weigh more. Again, more of that coming as he describes the advantages of stainless steel.
The interesting thing about 300 series stainless steel is that its properties at cryogenic temperatures, its strength properties increase dramatically. So if you were to look at the material properties at room temperature, you'd be like, oh, it's not that great. But now go look at the temperature properties at liquid oxygen temperature. Oh, actually much stronger. Also, no meaningful increase in brittleness. So it still has high toughness at cryogenic temperatures. It is much stronger, depending on how cold you go, up to twice as strong. You can also cold work it. So if you go sort of full hard cold work and do the final bit of cold work at cryogenic temperatures, you get outstanding strength properties, which are roughly equal to an advanced carbon fiber. For Starship, both the fuel and the oxygen are cryogenic. So this helps a lot. Whereas for Falcon 9, you use cryogenic oxygen, but kind of room temperature kerosene fuel. So anyway, we're both, this is quite a long explanation, hopefully interesting. If both fuel and oxygen fuel and oxidizer are cryogenic, now you get the strength properties in the primary structure of both tanks. So both are very strong, very tough and resilient, also very easy to weld stainless steel. And we started off with stainless steel 301. That did have some fracture toughness issues at cryogenic temperatures. We switched to 304, And now we developed our own alloy, which is 30X, which is better than either 301 or 304. And anyway, so now stainless steel only costs about $4 a kilogram. So we went from $130 a kilogram advanced carbon fiber to $4 a kilogram stainless steel, from 120 plies to 1 ply. It's just coil from the mill. Basically the same strength and very high toughness and resilience. And don't even need to paint it, which is great. Paint on a big vehicle weighs many tons, and it's quite difficult to paint big things. So but now there's another advantage. Obviously, you can tell I'm a huge fan of stainless steel. Stainless steel and I should get a room or something.
Just another bit I loved in the middle of a serious conversation about engineering. I'm a big fan of stainless steel. We should get a room or something. Just so comical. Like, he just drops that little comical bit in right in the middle of this intense engineering discussion. I love his ability to do that.
In making the vehicle reusable, so now it's coming in very hot. So the ship is coming in at hypersonic velocities, coming sort of kind of like a Mach 25 entry velocity. So this would just obviously just melt it. But if you've got steel, your melting point is much better, higher than aluminum, and you can handle much better temperatures than carbon fiber, because the resin tends to have problems. Like, you can basically go, anything much above, say, 200 Celsius, or for carbon fiber or aluminum, is you start falling off a cliff from a strength standpoint. But for steel, you go 800, and it's fine. Even 1,000 can be fine. So for the ship, this means that the heat shield mass is significantly reduced, because the heat shield mass is determined by the temperature on the back of the tile that then transmits to the hull. So if the hull is steel, you can have thin heat shield tiles, whereas if the hull is carbon fiber or aluminum, you have to have thick heat shield tiles. And you also need no heat shielding at all on the leeward side of the ship. So it is actually lighter than the most advanced carbon fiber vehicle.
Just love how Elon was able to break down all these different advantages that steel has over carbon fiber or aluminum-lithium, that you don't need extra things. Yes, steel is heavier than carbon fiber, let's say, but with carbon fiber, you need insulation here, you need lining here, you need thicker heat shield tiles, you need paint. And when you add up the weight of all the other things you need to make carbon fiber work, all of a sudden steel actually becomes lighter, and steel's cheaper, and steel's easier to work with because you can weld it. You don't have to do 120 layers of carbon fiber to make your thing. You just have one layer of steel. So much easier, so many different ways, less cost, and it ends up being lighter even though steel is heavier overall because of all these other things that come into play. It was long, but that was a great explanation. There's a little bit more coming.
I thought that the steel substituting for aluminum on reentry made some sort of sense. I didn't realize any of the other stuff.
It's the right thing, and then it's just the cost is ridiculously low. It's like $4 a kilogram. Even for the special alloy that we're developing, although it requires like a mill run, it's not using anything super exotic. We might throw a little exotic spicy something in there, but it's going to be like 0.2%. It's still going to be like maybe $4 a kilogram, maybe $4.50. And then it's just very easy to weld. Yeah, I love it. It's great. And then if we want to just add something to, if you want to, it's easy to repair. If you want to, add a sort of something to carry some wiring or plumbing or whatever, you just weld it right on. It's super easy. It's great.
Thank you.
So there you have it. Highlights from Elon's Starship presentation to that group. Fantastic. A lot of new information, a lot of highlights of what's coming, when the first launch is coming. Looks like January or February. That intense detail you just heard about why stainless steel makes more sense for Starship. A lot of other great stuff. I kind of wonder, like, if you're on Mars, it's probably going to be easier to make steel on Mars than make carbon fiber on Mars too. So if at some point you decide you're going to start building starships on Mars, maybe steel is going to make more sense. I'm not really sure. Maybe you're going to 3D print on Mars. We'll figure that out. But so much other great stuff. Missions to deep space, radiation effects on astronauts. There's a tremendous amount of detail in here. Please share this video with a friend who's really interested in SpaceX Starship and space exploration. And of course, please check out the t-shirts, the Evolution t-shirt for Rocket Evolution. This is Starship here, and maybe there's going to be a bigger Starship in the future. I think Elon's poo-pooed that, but maybe we'll see. A lot of great stuff. What's happening with Raptor, Raptor 2, and then some future rocket engine. Tons of great stuff in here. So please check out the t-shirts, elonbits.com. Check out my other videos. Support this channel on Patreon. Thanks to the Vasa Law Firm in Sweden, all my Patreon supporters for helping this channel grow. Check out my political channel, The Daily Lie. Link to that in the description below. And thank you so much for watching.